I believe in this weekend, a weekday of complete 1 week, you might have tried something. Oh, okay. So then what is the point of giving assignments? I think, if I can recall, oh, it's taking time to load it. This is what I have given you as an assignment that we had to, like on a data set, you need to, based on, I have given you solution as well as I just asked you to mimic what I have done into data frame. We have to do using PySpark, right? This was a question. So we had, how the problem statement was. We had a huge amount of data set in COVID-19, and this data set I have given, and I asked you to observe the data set first. Then using that, we filter some data of India and other countries. Is my screen visible to all of you?
Yes.
So just filter the data based on the comparison of most effective countries. Okay, so this is the data, right? Then the neighboring country from India. So we filter the data. That's for Pakistan, mainland China, Afghanistan, Nepal, Bhutan, Sri Lanka, Bangladesh. And then we made a case to display the data set basically. Once we did with that, then we had converted the date into date time format. This is your data. We converted into date time format because the date was not into certain schema. So we imported date time and then we use this to convert into date time format. And that is how we have this observation date afterwards. Okay. So based on this observation date, we did some visualization. So for that purpose, we have converted the date into date time format of all the data, and then we printed the schema to check. Basically, we printed the schema, and then we group by the data based on confirmed, alias, and recovered cases. So we have taken up the data based on the observation date, let's say from 2024 30, the total cases was 304 confirmed. So we group by data based on some dates. So here is some certain data recovered and all. So we have taken up this data. Then we group the data based on date here again on other countries like for Italy, Pakistan, China, Sri Lanka, Bhutan, like that. And then again, we had added the week column to perform weekly analysis. So how the COVID cases were increasing on weekly basis. So what is the observation date for weekly basis? So for this, we have taken India date wise with column week of the year, that is the function, and then week of the year, India date wise observation date. So this data we have taken up. And then the same we have done for some other countries. Then we have imported a window function to partition by, okay, based on observation date. Okay. So I'll show you something. Here is our data. If I go into the recent, I don't know what is happening today with the servers. It's very slow. Anyways, so the idea is to give you some heads up. So, like we can do this, this is something that I've asked to do that, okay, using PySpark. So we had what is the impact of lockdown one, lockdown two, the whole observation you need to calculate, right? Like with the help of all the functions that we have looked around it. So that is the idea basically that you need to solve. So anyways, it's okay. Um, I'll share you in some time and we'll be moving further towards. So let me just quickly walk you go through what we have completed and then we'll be moving towards something else. It's a complete, first we understand it from the data engineering perspective and, in data engineering, then we discuss about the detailed of how the data warehousing happen. Okay, and afterwards we move towards the technology advancement happen that's called big data. And in big data, how the processing is taking arrived. you know, and this is something taken up as a like some small advancement happened and the Hadoop came into the picture. The Hadoop 2.0 came into the picture. What is the SDFS? What is Yarn? Okay, what is map reduce? Then we uh, then we move towards Spark and their architecture. Okay, we discuss the detail of a Spark architecture, like how from the Spark context communicating with cluster manager, and then the driver nodes are working towards that. What is the process of DAG? Okay, what is Sages? We discuss all of them. And once we are done with this, then we move around, like some observability of Spark and tuning of Spark actually. Now, just a second. So, yeah, I mean, that is we have discussed. Then in detail, we have discussed about Databricks and we have discussed Databricks and then the Spark Ambly functionality, then Spark streaming. Okay, so these are the detailed stuff we have discussed, and then we have, did some Spark optimization as well as, yeah. So today we will be going to start with a new topic that's called Snowflake. This is the idea. So anyone have ever worked on Snowflake?
A few of us have just started to work on it, Dipesh.
What?
No, a couple of folks have started to work on the Snowflake
Mhm.
in
So
recent.
anybody would like to make some point here? According to you, what is Snowflake?
Yeah, so basically, Snowflake is a cloud-based data warehousing platform, right?
Mhm.
Where basically, like we can create the warehouses and then utilize it for multiple purposes, right? For machine learning, as well as data analytics, BI, etc.
Correct. So if we just going to consider Snowflake, right? So, uh, Snowflake, if I have to just tell you, Snowflake, if I have to just tell you, we're going to talk about, if I'm audible, right?
Yeah.
We're going to talk about this Snowflake part. Okay. So as I mentioned, Snowflake, as you guys have also mentioned, it's a cloud-based data warehouse tool. So yes, of course, it's a cloud-based data warehouse tool. So Snowflake is currently a data warehouse built on, for the cloud as a SaaS product. Okay. So Snowflake, we can say that is a data warehouse built for only the cloud as this software as a services product. Okay. So basically, it's connected on clouds, and the major source of clouds that is connected on this, that is Amazon Web Services. Okay. It's connected on Microsoft Azure as well as and GCP. Okay. So this, if we talk about this Snowflake, oh, sorry. Actually, you have to wait for another 2, 3 more minutes. There is some emergency call I need to take. So I believe if you are all are okay, right? Let me. Okay. Yeah. Sorry. So I was talking about that it is built on the top of AWS, Microsoft Azure, and GCP. And so my screen visible, right?
Yes.
So basically, since it's mentioned on GCP and all these platforms, we can use it. And this Snowflake will help us to manage the structured and unstructured data as well. So it is used to manage the structured and unstructured data. And it can serve data warehousing. What all the things it can do for us? It will do data warehousing. Housing it can do complete ETL process and data engineering process can also be done, and the data science part and machine learning and all can also be done. So that is the capability of this. And so means that's something we can do that. So there is no when you are actually supposed to gonna use the Snowflake. Mm, so Snowflake does not comes with any on-premises, means they don't have their own, like a storage system or something like that. So there's no on-premise version like in Databricks. You had an option to use Databricks file system or something like that. But here you did not get that kind of thing. But yeah, it's available the compute, transfer, and storage cloud options that is available over there. So that you can actually check over there. So there is no on-premise version, but instead of that, you can use on Snowflake instead of that, right? So yeah, I mean that is what about Snowflake. Okay, so let's quickly create an like an account, and we will try to have a look how does this Snowflake actually look like. And so for that reason, I had created my account, but you need to go into Snowflake. Okay. So either you can actually create start profit. So basically, it will give you 400 rupees of credit. Okay. So when you start going to create a Snowflake account, it's going to create to give you a trial version, and that is free for with $400 credit. So you can use that. Why it is happening today every single. So what I'm trying to tell you is that either you can go with the dedicated link also, okay, and that you can look around it. So this is the user interface, okay. So here, like you can see that here you have all this. This is the home section, okay, and you can have your projects, whatever projects you are working around it. So these are some certain projects worksheets we are available with that. So load sample data, some examples are already there, and TPC, some basic examples you will get here. Okay. Or either you can create your SQL worksheet. So if I just click on my SQL worksheet here, you can see that it will allow me to start writing from the data sets wherever I wanted to write it up. Okay. So here it will going to show me that what wherever is my data sets, it will start. You can start writing your selecting your data sets or whatever your tables is there, and you can start writing a query. Okay, and not just this, but this is showing us before running, you'll need to set the context. So role, data warehouse, database schema. So we need to select the context, whatever is your context, and then once you select, you can run a single query or multiple queries here. So run all means window shift enter, or you can select the specific one. This is showing us explore query results. You can explore the query results also here. Okay, that is what it is showing to us. Try using the object explorer panel, so we can explore that also. This is something. Now apart from that, instead of using this language in a this one, see here, once I write here any query, you know I can direct to start going to show me some certain features, and you can start writing. This is the database, and these are the worksheet it will show. Okay, so there are few sample data sets are here. Okay, and that's something you can actually look around it, and you can create. the computes and the stuff over here. And the compute access small is running on the top of it. The status size, mini cluster, auto suspend. So these are the stuff that is a user interface basically, right? You can add data from databases. You can connect from marketplace apps. You can connect from Databricks and you can query the history. So these are the cost management and all. So that is something that you can look around it and you can actually use the local file and you can create a notebook. So here you can create a notebook and in this notebook, like we were creating the Python kind of file. Similarly, I can write down my query and you can start querying here as well as. So that is something also possible in this notebook, and you can see that you can start writing like in a database we were doing. So you can actually start writing this, and similarly, you can ask queries, and you can see that in a notebook format you can start writing. In a Python also cell you can write down like my def cell to pandas, and then you can start writing the queries as well as. Are you getting my point? Hello?
This notebook concept is similar to Databricks notebook.
Correct. Their user interface are different. Yeah. So that is something. So select Friday, Sunday, chance of snow. So there is something chance of snow, snow day, XY chance of snow, and then we are predicting something like that. So you can write down in Python, you can write down in SQL, you can write down in Markdown. Markdown is just to add the name or something like this. So you can start writing it and it will start. You need to first select the database, select snow day. So data base should be collected. And then, once the data frame got, stuff done, and you can start writing the query. So that is what about something like this you can do. So here you can do write a SQL worksheet, Python worksheet. You can create new notebook. You can Git repository. You can connect. You can look around the tables. Okay. You can stage the table from Amazon S3, Microsoft Azure, or Google S3. You can view those stuff. Multiple views are there. I will be coming on these points. They will be discussing those stuff as well as. So that will be the stuff. So that is all about. So please log in everyone and please let me know if you all are done. Just allow me 2-3 minutes before we'll discuss more on the top of it. So you first log in and try to look around the user interface, all of it.
Dipesh, I have one question.
Hmm.
Why do you need a Snowflake data warehouse or data lake?
Good question. So basically, we have varieties of, uh, you know, uh, like data warehouses are available. Okay. And like we have Synapse Analytics and we have multiple other softwares are available, right? So when we talk about Snowflake depends, you need to use on a specific use case. Okay. Uh, you know, like see, Snowflake or either you're using Databricks, both platforms is powerful, but they are slightly different in the process of their data architecture. So I will come on the data architecture side, then you will get to know. So the comparison, if we do that of Snowflake and Databricks, so see, Snowflake primarily focus on the optimized data warehousing and SQL-based analytics. So if you will discuss that in detail. So the main need of running SQL queries for data analytics, business intelligence, Snowflake is likely a better option when you are working on the data warehousing part. Whereas Databricks is centered around big data processing, okay, or machine learning. And since Snowflake is on cloud and you can do all the analytics, you can do all the data warehousing process. So that is why it is more efficient.
Okay. Okay,
Yeah.
but in data lakes, all this can possible through the consumption layer that we have in data lake, right?
Mhm.
So
Yeah, consumption
that
you can do, but you need to use a stack of another technology. Here you are having an assimilated feature of compute, storage, like architecture, better architecture. So that is uh, the good thing with this Snowflake.
Mhm. Okay.
So Dipesh, I want to understand more deeper, like, the difference between Databricks and Snowflake. As in, like,
Mhm.
when you say that Snowflake is better for warehousing and all, right? Why is
Mhm.
it so? Like, and why Databricks is not?
As I mentioned, the Databricks are majorly involved with data engineering process like ETL and all, right? And big data processing, machine learning. Databricks. You need to use when you wanted to do advanced capability of ETL processing or data science or ML capabilities. Okay, so there you can go towards. You can focus majorly on the Databricks primarily. Whereas you can also use this as a pipeline for ATL, and then you can store into Snowflake. Okay. So Snowflake are majorly being prepared for, optimized for data warehousing. Okay. So when we talk about the any structure or unstructured data, Snowflake are mainly optimized for structure and both unstructured data for JSON, Paracut file, and since it can do advanced data warehousing, advanced data sharing options are there. Okay. Separation of, storage and compute system. So these are some advanced capability of Snowflake.
I think same kind of things we have in database also. We have Unity catalog to store data, to
Correct.
see data. We have Delta Lake, right? We have
Mm.
computing power clusters, right? We have
So
SQL warehouses, right? So why, Snowflake has a upper hand in data warehousing?
the way it is store the data, the architecture,
Okay.
you know,
What is that?
uh, so we'll come on the architecture, this we'll be discussing their shared architecture in the Snowflake, and how it is more useful. So basically, when we talk about Snowflake are optimized because of data warehousing, and the way it is optimized in their architecture purpose, the shared architecture and the cluster management in terms of the data management and the processing layer. So the way it is, and the intuitive process of Snowflake interface, you can say that, and minimal configuration required. That's why it's easier for clients, and they are started using this. So Snowflake configuration allow user to load data, run queries like in Databricks, but the advanced feature of Snowflake is the optimized way of data warehousing. Deep optimizations can be done on this. So that is something the good thing with Snowflake. It's have automatic query optimization also. You are aware of not. And since it is optimized on these queries and all, the SQL queries run very faster on it. Minimal tuning required. Got it?
So on the architecture front, you will discuss more when we discuss Snowflake architecture.
Correct. Also, just for your quick understanding, cost management part is also plays a role in Snowflake because Snowflake operates pay-per-use model. Okay, they charge for storage and compute separately. So this is particularly useful in scenarios where you need only intermittent compute, example analytics queries and all. But you have a significant data storage need, Snowflake ability for automatically suspending the compute resources when not in use. It also help to optimize cost. Whereas in Databricks is cost effective when you are doing a big data processing or ML algorithms and all. So that is how. Means there are so many. See, of course, you have to understand one thing. The same thing you can do with Synapse Analytics also, what you are doing with Snowflake. The same thing you can do with, Redshift also. The same thing you can do with, there are so many tools. It's all the market. Okay. The market is very huge. They come up with some solution. They see a unified solution. Snowflake have a unified solution of everything as in data warehousing we may require, and they are also making something out of it. So that's what I understood. Of course, we cannot focus on one tool only, right? We look around the options. Snowflake gained popularity because of their cloud-based infrastructure, a different tool. Because on AWS, if you see, there are thousands of services, hundreds of services. Now, a persons, those who are using some services are keep busying themselves into other services. So when they come up with a new pitch of providing a new brand new software that help you everything, of course people started gaining popularity. Once it's gaining popularity, they started adding so many features on the top of it. And since it is more optimized on SQL, and the old school people, those who are only working on SQL from so long, they also started liking their way of optimizing this stuff. And that is, wow, as per my experience, what I have observed in this. So that is it. Please log in. And uh, if I have to tell you, the Snowflake, you know, Snowflakes is primarily designed in such a way, because the idea of Snowflake to have a kind of data warehousing, modern cloud-based data warehousing solution that can combine the element of both shared disk, because we as like in our organizational requirement, we want a shared architecture of data warehouse also, because n number of organizations are allowing, n number of departments are accessing those things. So Snowflake architecture is a modern based cloud data warehousing solution that combines both a shared disk and shared nothing architecture. Okay, so this is the unique architecture that not every other platforms do have. Okay, so if I talk about what is the shared architecture, what is shared nothing, I'll just come on that, but let me just type down this for you. So Snowflake architecture is uh, cloud-based. So Snowflake architecture is nothing but it's a cloud-based. Oh, I'm talking about this. Yeah. So Snowflake architecture is a cloud-based data warehousing housing solution that combines elements of both shared disk and shared nothing architecture. Okay. So basically, this is a unique design, this unique design of shared nothing and shared disk architecture. It's a kind of a unique design, and that's not everyone actually provides. So this unique unique design allow for efficient data management and high performance query processing. High performance query processing. Are you getting my point? Why Snowflake is being used? Because it can do a better SQL query processing, okay, over Databricks and others, and that is the use case that's effect more. And because of this shared nothing and shared disk architecture, the unique design that's allow data management and high performance, uh, data management. Data management I already mentioned. Data management and high performance stuff into this certain layer. Okay, certain three main layers. So it's actually the process of this Snowflake are being divided as a three main layer is available inside this. Okay, so the key processing layer, the three important layers of Snowflake is Snowflake. Three important layer is, anybody wanna tell me if anybody aware of that? Hello. So the first layer is called database layer. Okay, let me first write down the diagram. Basically, the diagram is into such way. So the diagram is that there is three basic layer. What are the three basic layer is? One layer is called the database storage layer. Database storage layer. So there is all the databases are here. Okay. So query processing. Okay. Second layer is the query processing layer in which virtual warehouse will be get processed. Virtual warehouse. Virtual warehouse will be get processed. And on the above, there is a cloud services. Cloud services on which the data and authentication, optimization, metadata management, everything is there happening over there. So here it's a authentication and access control. Okay, so you are doing infrastructure manager, you is an optimizer, metadata manager, and then there is the enhanced security part. Okay, so that is something, are the three major layer of this. Now, keeping this in mind, let's understand one by one all the layers and understand what's the meaning of this basically. So if I talk about the database storage layer, the very first, okay. So in the database storage layer, if you talk about, so there is a centralized repository, data optimization and micro partitioning happening here. Hello, if I'm audible to you, all of you?
Yes, Dipesh.
Yeah. So in the database storage layer, there is one centralized repository, data optimization, and micro partition. Okay. So when we talk about the centralized repository, okay, Snowflake actually use a central data repository for storing structured and semi-structured data, which is accessible from all the compute nodes. So here it's a centralized repository for structured and semi-structured data. Okay. Whereas data optimization is nothing but datas are stored basically optimized, compressed, and columnar format. Okay. So when the data, there is a storage layer, we have these three available storages are there. So data optimization, it's kind of a stored in a optimized, compressed. Let me write here. In this, data is stored in a optimized optimized compressed and columnar format. Okay, so that's utilizing cloud solution, utilizing cloud solution, cloud solution like S3, Azure, Google Cloud. So these are the optimized solutions that we have. Okay, and that's something we can look around it. So that is. Then there is another layer of this that's called micro partitioning. So here data is divided into a small partition to enhance performance, basically. So micro partitioning is, some small partitionings are there, micro partition data are there. Okay. These partition datas that's available in the storage layer, okay, are divided into small partitions, and the performance, enhanced performance to be received for that order, the micro partitionings are available inside this. So that is the idea basically of micro partitioning. Okay. So that is the first data storage layer inside this. So this is called data based storage layer. Okay. The second one, yeah, this is I'm talking about Snowflake architecture. The second one is this. It's called query processing layer. Okay. The query processing layer. So what is query processing layer and how does it work? Basically, query processing layer, where we actually run the queries and the process actually taken place. So it's virtual warehouses where queries are getting executed using all the virtual warehouses, which are nothing but it's happening MPP. So MPP is nothing but a massively parallel processing happening in a computer cluster. That's what the query processing layer, the virtual warehouses are there. So in query processing, there are some virtual warehouses. Virtual warehouse. So virtual warehouse is nothing but it's a queries. Queries are executed using virtual warehouse. Okay, which are MPP, called massively parallel processing. That's having compute clusters. Okay. And each warehouse actually being operated independently. Okay. So operates independently. Okay. And since it's operating independently, it's allowing a concurrent processing. Okay. So for that reason, it's allowing concurrent processing without any resource contentions or, lot of that. So one is the virtual warehouse and query processing layer, and another one is the elastic compute. So basically, what happened? This virtual warehouse has to sometimes scale up, okay, or down based on the workload. So this elastic compute provide the flexibility of resource allocation. Okay, so there is also elastic compute. So this virtual warehouses has to, sometimes can scale up and sometimes down as well as. So based on the workload, okay. So the demands based on the workloads and based on the demands. So this flexibility of resource allocation is there. That is what the query processing layer will help you. Yeah, that is all. And the cloud services layer, the cloud services layer, because it's are connected with other services layer of clouds. Like, so the cloud service layer are this. The cloud service layer are the management services. So basically, the layer of cloud, one is the management services. Management services. So basically, this layer actually coordinates activities across Snowflake. Okay, so this layer coordinate activities across Snowflake. Okay, and it's allowed to managing user authentication, query optimization, and metadata management. And metadata management. Okay, so that is what this cloud services will able to help us with, and you know, that's able to manage, and also it's impact the security stuff. Means security stuff is there. That is something we look around it, and we take care of those things. So here the security features been encrypted in this cloud services. That is something big there. So there are three layers, as I mentioned. One is the cloud services, one is the query processing, and the third one is the database storage. Okay. So that is what it's meant to be the basic architecture. It's an overview of high level architecture. Okay. But there is a detailed architecture is there that we will be discussing. If you have any question in this, please ask.
Dipesh, how does this cloud services layer perform the query optimization? Because the same is being processed, is being done in the query processing layer as well, right?
Uh, Main, your point is to ask is
So how
like
does this
how?
cloud services layer does the query optimization? Because the same query optimization is also being done in the query processing layer, right? Where we have multiple virtual warehouses
Mhm.
which runs independently and does the query optimization.
No, there is a, like what happened basically. This is the high level understanding. I'm telling you how the snowflakes are based on, like how the snowflake is, set up. Okay. The how we are query processing, how we are doing, that's a different architecture. Just you please understand one thing, means there are three component of Snowflake. Okay. This is to make you understand the components of Snowflake. So the component of Snowflake consists, one is the database, then where the processing will happen, and then the cloud services are there on which all the management part of Snowflake and everything is happening over there. When you do a query processing or something, it's happened within their distributed system architecture or not shared architecture. Okay, so these two are different things. Are you getting my point?
Yeah, Dipesh.
Yeah. So this is the high level understanding of how snowflakes are based on. Okay. So snowflakes are based on this particular architecture where, this, the architecture overview of Snowflake, how does it look like? Now it's when it's come to the Snowflake system architecture, if we talk about the system architecture, the snowflakes, as I mentioned on the top, okay, Snowflake architecture, Cloudbeat, and it's combined the element of both shared and disk and shared nothing architecture. Okay, so we'll come on that. We'll be discussing detailed about shared disk architecture and shared nothing architecture also in detail. Just a second. Just for a high level understanding, I'll be telling you, if I just tell you the distributed system architecture, that's called shared disk architecture. I'm talking about the distributed system. So the system, how does the system work? So if we talk about the distributed system architecture, okay. So Snowflake basically, um, if you just look around the Snowflake process, Snowflake actually, how simple data architecture with Snowflake actually works. Okay, how you can work with Snowflake basically, or how this the processing actually take place in this that we can look around it. There is a certain process that has been taken up. Okay, so you might be reading the data from some places, and then that data actually been processed within your services, and the data actually taking places, and then the data completely do ETL and everything we do around it. So that's something we can actually understand. So let me just quickly tell you. So well, let's say you have any sort of data. Okay, you are reading the data from any data sources. You are staging the data somewhere, right? So how the service layer of this actually taken places here is mm, in this way. So basically, what happened? I will be telling you the reference architecture. Kind of a not the shared or not disk architecture. I'm just telling you high level once again the architecture, so that later on when I'll bifurcate the process, you will be able to understand in detail. So let's suppose you have any data sources. Okay, you have any data sources. So in this data source, let's say you have external data, any external data. Okay, and either you have some on-premises data center, you have any on-prem data center. Okay, any kind of data sources you are having, and that data sources you are staging somewhere, because staging is required, right, for a data lake, and also you have done some staging. Okay, so here once you did some staging, like you are putting the data into Amazon S3 or blob storage or anywhere, right? Once you're done, so in Snowflake architecture, when you going to utilize in Snowflake architecture, so in Snowflake, what will happen? You have some service layer that your cloud service is helping you. That's the cloud service is helping you with security, markdowns, management, okay, management, optimization, transactions, data sharing, and all. And you are reading data. You are reading data. There is a snow pipe in Snowflake. I will discuss that part. There is a snow pipe in Snowflake. Okay. Or with the help of their ETL architecture, ETL virtual warehousing architecture, there is a ETL virtual warehousing architecture. So here you can do ETL using their virtual warehouse, and this is their compute layer. Okay. So here you have, okay, here, like your marketing, virtual warehousing happening, or whatever it is. Then here on the top of something, there is a storage layer. Okay. There is a storage layer with the help of you are writing or doing virtual warehouses. With the help of virtual warehouses, you are querying the data. Okay, you are querying the data, and then you are again pasting with the virtual warehousing in some other processing. So you might can communicate with multiple virtual warehouses. Multiple virtual warehouses are communicating with the storage layer. So this is the high level way of exploring the data, how the data are actually happening, right? So when it comes to a detailed way by which the distributed system architecture happen. So here in the distributed system architecture, there is a one component that's called shared disk architecture. Okay. So in shared disk architecture, okay, each node shares the storage disk, but it has its own memory. Okay, so basically what happened in this process, let's say you have multiple computer nodes, you have cluster, CPU, and memory. So cluster, node, CPU, memory. Similarly, you have multiple other cluster, node, CPU, memory, and there is a network communication. And this network communication have some disk storage, disk storage, disk storage. Okay. So what is happening here? So in each node, okay, share some storage disk, okay, but it has its own memory and CPU. Okay. So multiple nodes or multiple compute resource like BI dashboards, in that. So all the ETL workload access the single storage disk in the shared disk architecture. So system in this process becomes slower as we are onboarding more and more ETL workloads. So there is a single storage system that is single point of failure, over there. But the benefit of this is, read and write operation are consistent and efficient because it's not having any distributed storage. So in this distributed architecture of shared disk architecture, multiple nodes or multiple what compute resources like VI dashboard, IDE, ETL workloads, access the single storage disk. System becomes slower, but benefits comes here is read and write operations are consistent. And efficient because it's having a distributed storage. Right? The disadvantages is because distributing locking and two-phase commit is happening. So that is a kind of a disadvantages are there. Whereas we'll come on the we'll be discussing the shared nothing architecture. So shared nothing architecture, if we talk about shared nothing architecture, in shared nothing architecture, there are so much of the differences than the shared architecture. So basically, in shared nothing architecture, there is no node sharing any resources. Okay, no nodes are sharing any resources with other nodes, and data is keeps shuffling across all the nodes throughout the common network connections. Okay, in this one, like if you have any one of the disk, so disk is compatible in such a way that it is not sharing anything, but there is a network communication between them, network communication, and again cluster and node, cluster node, cluster node, cluster node CPU memory, cluster node CPU memory. Yeah. So there is a disk storage. Yeah. So, in this process, as I mentioned, in shared nothing architecture, uh, no node shares any resource with the other nodes, and the data is shuffled across all the network communications. Okay. The advantage of this is storage and compute are tightly coupled to each other, and because more nodes can scale horizontally. Okay, that is a good thing with the shared nothing architecture, and storage cannot scale independently. That is one. Uh, Disadvantages is the data actually need to be shuffled across the network. So it will be overhead when there is a lot of data. Means when there is a lot of data, the data need to shuffle across all the nodes. So that is how the Hadoop, Cloudera, Impala, and Cassandra work, because that can actually into a distributed architecture, and since it can happen into like the Cassandra or Cloudera, Impala have this feature where it's in a distributed, it can actually assimilate any one of the nodes. So that is the distributed shared nothing architecture. Any questions?
But how does it impact the performance of the query?
Its performance of the query is happening now because in the shared architecture, excessive redundancy happening. So shared architecture because it is high available. Well, scalability is slow. Okay, and scalability you cannot do that in this process, and the data is partitioned and stripped within the storage array. So when the data is partitioned and stripped within the storage array, like, so when you wanted to tweak certain joints within multiple other disk, okay, so it has to look around the other disk, and that's the performance got reduced. So that is what in the shared nothing can't possible, but in shared disk you can actually look around it. So that is how the performance also impact. And there are other parameter also.
So shared nothing has better performance over shared disk architecture.
Uh, So, like if I call in terms of it depends. So, shared nothing architecture and shared disk architecture, it's a approaches of managing this data storage and processing. Okay.
Hmm.
So it's a approach of for data storage and processing. So each have some certain things. So in terms of memory, disk storage, you can see that. But if you are talking about the performance,
Hmm.
performance is high performance. You can achieve in shared disk architecture also and shared nothing architecture. You need to have your understanding of how you are storing the data. So when we talk about the high performance for distributed parallel workloads, queries can be processed in parallel across multiple nodes. So when in a shared disk architecture, you have parallel processing happening into multiple nodes, the performance will increase. Okay. So similarly, when you have a data that contained not so much paralleled and something, there you can get the achievement of performance in the shared disk architecture also. So share nothing architecture also. So it depends. So it's just a storage purpose. Okay, storage purpose and management purpose. We look around these two architecture.
So when do we go for shared nothing and when do we go for shared disk?
As I mentioned already, no. So
You're saying
so
the
like
approaches are different, but both are aim for higher performance.
see, shared nothing architecture actually offers superior scalability and performance over distributed system, while because shared nothing architecture are not jumbling up to the multiple datas over there. So deciding, you are asking how to decide when to use shared nothing and shared this architecture depend on the specific use cases as I mentioned. So when you want scalability, you are talking more about performance, okay, system constraint when you have. So then you use the architecture. So when to choose shared nothing architecture, when you wanted to add up some horizontal scalability, okay, then you can use shared nothing architecture. When you having a big data system where you are writing high throughput of data, there you can use horizontal scalability. So use shared nothing architecture. Performance are high in parallel processing in shared nothing. So of course you can choose that in that case also. Whereas when you're using shared disk architecture, when you want a very high availability of data, then you can use that. So these are the conditions. Or you want any easier data management. Yeah, I mean, that is the stuff I was talking about between shared disk and non-disk architecture. So the differences I told you, and a few differences that if you wanted to list around this, as I mentioned also. So in shared disk, like we just quickly walk you go around. Um, Share disk and so in this share disk, the expensive hardware with redundancy to handle component failure. Then we look around it. So because share disk, you can keep, doing the high availability is required for this purpose. More stuff is required because scalability is there. Sorry, low scalability is there, but high availability required. Okay, and low scalability. Okay, uh, here it is typically built on commodity of hardware, and nodes is low and system available is high. Okay, low nodes are low here, but systems are high. Okay, highly scalable, and this is preferred when OLTP system that required ACID compliances. This is preferred when an environment with high read and write rates. High read and write rates. We have already discussed the multi-shared architecture where multiple virtual machines are there, and Snowflake here actually follow the hybrid approach, which is called multi-clustered and data architecture, where we have virtual machines and single integrated system there. So this we have discussed this, and storage layer and these components we have already discussed in detail. And we have discussed virtual warehouses, virtual machines, compute layer, right? And cloud layer also we discussed, right? So uh, like there are few things that in detail life cycle of Snowflake query, we will be discussing here. Know how the query been processed on this and how, this actually works. Okay. So that I will be discussing with you. So life cycle of a query, a Snowflake query, we'll be discussing. So basically, whenever see the very first query that you're gonna do, where we are doing, we do using on web user interface, right?
Web services. Sorry, cloud services.
Yeah. So on cloud service using web user interface. So whenever a user coordinate or communicate, somebody have asked what is the process. So that's what we are discussing. So we are discussing the life cycle of query, Snowflake query. Life cycle of Snowflake query. Yeah. So this is important. So please look around it. The very first thing, user actually submits their query on via web UI. Web user interface is there, okay? Or there is Snow SQL. Snow SQL is also there. You can do that. Some connectors are also came, JDBC connector or ODBC, right? So these are some certain connectors are there that we can actually process. So from this web user interface of this is a web user interface. This is web user interface. Okay. In this web user interface, we actually when we take this ahead here, and we are actually processing the cloud service layer here. This is the cloud service layer. Okay. So in cloud service layer, okay, it will go to the compute. Okay. It will go to the compute here. And so it would be extra small compute, let's say. Okay. It could have a smaller compute. Okay. And it could have a medium. Medium would have more computes. Yeah. So this is a X is small. X is small. This is the small. And this is medium. Medium, right? And this all will be going to our storage. Okay. And these storage are like this. Yeah. And so this is the user interface. Okay. Now, when this is a user interface, okay, what actually happened? What is the process of, you know, uh, like what actually happened when this Snowflake actually query process? What is the whole step-by-step approach we used to take? Any idea? Like, if anybody have experience working into this? Hello?
Snowflake team.
Please, let's make a little interactive. You guys are just listening me. Okay, I understand few people are not aware, but few are doing working. I have seen Nitin or someone last time, Nikhil or someone who was working on Snowflake. So I believe you guys can give some input.
Jayant, any idea?
I mean, yeah, not in Snowflake in general. So when a user runs a query on the web or something, it'll hit the database, process the query, and gives you the results. If it is repetitive, then it'll hit the cache and then it'll get the data from. I suppose here the caching happens at the cloud service layer. Is that right, Dipesh?
Correct. So what happened, generally, whenever a query is issued, the service cloud service layer, parries the query. Okay. So let me write here. Is my writing good today?
It's improved a lot.
We can understand it in you.
Yeah, so I'm writing little slow. Sometimes what happens, I am thinking something faster and then I started also writing faster. So that's how the writing got. Yeah, so whenever a query is being issued, the services layers actually parses the query. Okay. So when the service layer passes the query, it started compiling it. Okay. And then determine which set of partition hold the data of interest and flag them for scanning. So let me write here. So it parses the query and compiles it and determines which set of partition hold the data of interest and flags. Scanning. So, that is what the very first thing happened. So whenever a user submit, this happens. So user can submit query via any supported client connector provided by Snowflake also. So it's not just like from their user interface we are doing, but with other stuff we can do that. So we could have submit using, some other sources as well as, so let's say if user are submitting, can be submitted by other sources, right? And not just this, but not talking about the sources, but again, once the submission happened, the cloud service layer scales up down the warehouse depending on the indication provided by the X small or X large. Okay. So the cloud service layer then scales up basically. And, scales up and either down based on the warehouse depending. Okay. And on the indication basically provided by so like depending on the indication provided by the users, okay, whether it's a extra small or extra large. So these something depend on extra small or large. Okay, let me put in. So yeah, I mean this is one something. Then afterwards, what happened when the cloud service layer creates a session and check if user credential is valid to use Snowflake account using MFA IP address. Okay. So what happened? When the processing happened from the cloud service layer scales up and down. So the cloud service layer actually create a session. Okay. So the cloud service layer will create a session. It will create a session. It will create a session. Okay. And and it will check if user credential is valid, to use Snowflake account using MFA and IP address and also flavor. So once the authentication is done, once the authentication done, what will happen? There is a logical. This is quite important. So once the authentication is done here, we make sure the logical plan, of the query gets created. So here, once the logical plan, once the authentication, then the logical plan created, and not just this, but once the logical plan created, all the objects and operations in the query, including the warehouse validation, if the respective user has privilege to access that object, it will get look into that. So all object and operation in the query will proceed further. So I'll write this because these all are. So basically, all the objects and operations in the query, including the warehouse validation, has privilege to access to the object will be checked. And then the optimized query plan is going to be generated and submitted to the computer layer. So the optimized query plan is generated and submitted to the computer layer. Okay. And then it's also resume the cluster. And if it's shut down or spins up, if that got shut down, so what will happen? Cluster, it actually once the cluster get used, it may can be shut down, or a down spin can be happen based on the requirement, based on the need. Okay. And finally, once the computer layer reads the data from the storage layer and provide the result to the user, this processing is keep happening. Whenever you're getting to query, then the processing, the computer layer read the data and will do your work, will read the data, and from the storage layer, and then your she show you the results. So this is something. If you want, you can take a screenshot of this. This is the life cycle.
Dipesh, what happens to the cluster after the optimized query plan is generated?
Cluster can be, cluster go, resume or shut down based on the requirement. So it will shut down as well as. So, or downgrade also. So that is auto downgrade option is also there in Snowflake, right? So that will happen.
So all this happens automatically, or should we configure it in that way?
So there is a process in Wildlife cluster definition. So in this the process, the Snowflake, the virtual warehouses, I can be auto scaling. There is a feature basically in Snowflake. You can do either auto scaling, auto shutdown, downgrading. That you can define. So in the query also, in the compute resource, basically when you are doing, so that you can define the virtual warehouse is downgraded, auto suspend. Generally, we can configure the timeout between 5 minutes to 10 minutes, or maybe apart from that. So whenever a new query will arrive after suspension, the warehouse automatically resumes the run the query. Or these three features are there: downgrading, that's called scaling down; auto suspend, that's called shutdown; and auto invoke also kind of a feature which auto run the process. We can define it.
Okay.
Dipesh, X small, small and medium, is this our cluster node?
Which one?
X small, small and medium, is this our cluster node?
It's a storage layer you are processing. This is a compute service. Yeah,
That is query processing layer.
yeah. Query processing layer.
Okay.
That means cluster are nodes.
Clusters are nodes. Yeah, so we can use that. So that's the process of defining your cluster inside your Snowflake. You can define that. Like if you have seen into EC2 instances, there is extra small clusters definitions, right? Similarly, here you can define. So since it is using the capability of EC2 instances or the compute services of cloud only, so we are defining the roles over there, mean like that. Yeah, I mean that is a life cycle basically. And let me tell you some versions. As I mentioned already, there are different versions of SQL, and like when we were choosing that, the type of versions that we had available, and on-demand storage we can utilize in this. So there are certain things that we can look about, and so there was a standard enterprise, like
Business critical.
something, yeah, business critical, virtual private Snowflake VPS. So something, these are the stuff that we can look around it. And so what are the meaning of that? Something you can actually look to that. So so when we talk about a standard, so there are certain capability, what are certain thing that you can actually access. What are the things we can access? Let me just quickly tell you. Yeah. So see, some certain one that is called the standard enterprise business critical virtual VPS. You can say that is virtual private Snowflake. So it's a very business critical plus. So we could have used that. Uh, One is when we talk about the standard enterprise business critical VPS. So in the standard one, you have something complete SQL data warehouse is there. Okay, complete data warehouse is there. What additional in the standard plus? It's give you multi-cluster warehouse. Okay, so basically these are the feature of standard will be there in enterprises, means secure data sharing across region, 24 into 3 support, 1 day of time travel. So here it is 1 day of time travel you will get travel. Yeah, and here it's give you a 90 days of time travel. It can give you a multi-cluster warehousing. This like always on enterprise grade encryption is required. Here it's a annual relying on encrypted data, like you are not much relied on that. So these kind of advanced things you will get. Here you will get snow site. Here also you will get snow site. Okay, database replication you can do that. Database replication you can do that. You can create your own data exchange. You can do data exchange. You can do data marketplace access is there. Okay, you can have external functions. So what additional in enterprise you can get, as I mentioned, 90 days, you can get search optimization services you will have here. You have dynamic data masking is there, external data tokenization is there. Masking is there, external data tokenization is business critical, have some more, it's have a advanced support system. They call HIPAA. It's a data encryption everywhere, multiple private link supports you will get of AWS, Azure private link support you will get. So these kind of advanced things you'll get. And, that is how the different sustainability of this. And there is a on-demand storage and capacity storage is also there. That's something you can look around it. So these are the advanced stuff of, this Snowflake different versions you will get. Okay. Now, by looking more into this, that's advanced and all. Um, Once you have created your accounts, once you define the accounts, once you process the account, when you're creating the worksheet, you will be creating a worksheet. We'll have a look around it, how we can, like we will able to make, like the process of reading the data from different places. And then once we read the data, we'll be able to create our data warehouses. We can query the data warehouses. We can maintain using Airflow and these kind of things. That is also possible. You have any questions, you can ask them. Meanwhile, I'll show you what are the warehouses are there, how to create those warehouses, and not the warehouse, but actually, if you show, I'll show you here. It's our account, right? And this is the admin is here, right? In admin, if I show you the accounts, so accounts, you can create your ad accounts. Here you can see that this is your account standard enterprise business critical, correct? And you can create Polaris account. Okay. So you can see the dropped account here. Okay. You can actually see the user roles. So in the warehouse where I was telling you how to create a warehouse, here you can define what kind of extra small, extra large, 2x large, what kind of you wanted to create. That's I was talking about extra small, small something for that. So something you can define this up. Okay. For type the account you wanted to create, something you can define it here. Then that is something you can create in
Dipesh, one
warehouse.
question. Hello.
Yeah.
Yeah, while creating these warehouses, like in the Databricks, there was something like DBU, right? Database, sorry, Databricks unit.
Database utils. Yeah.
Unit, right? And similarly here it is credits. So how it is like how the cost is basically calculated here in Snowflake?
Snowflake, cost calculated on three things. One is your compute, one is your storage, and the uses of their cloud, you know. So it's calculated on three things. As I discussed this already, means it's a very good option also, because if you want just a storage, you can use for storage. If you want a processing, you can use for processing. If you want for warehousing, you can use for a warehouse. So that is the thing. That's a good thing with Snowflake.
So for storage also we need cost, you were saying, right? Means it's not as per the pay as you go, but if even if we store, we will have to bear some cost, right? Or how it is?
Cost.
Mm-hmm.
Yeah, you have to bear some cost.
Do we have any calculations or any formulas for that cost
There is a
calculation?
cost management. There is a formula. There is I think, a calculator. I'm not able to recall as of now, but there is a form calculator.
Yeah, because a computer
This is
will
the billing terms. There is a, yeah, this one. Here you can calculate. So how much you're using, warehouse size, what is the query in minutes, what
yeah,
is the
but then
cost?
if you see these options, right? So basically here we are just entering the query runtime and the cost per credit, which is as per the warehouse size. So here the storage factor is not there, right?
Storage factor it's not showing, but anyways we are using warehouse, right? So
The
uh,
warehouse is for compute, right?
yeah, we virtual warehouse is for compute.
Right.
So
Yeah, basically like if you want to tune the queries or like basically we should also take into consideration the costing, right? So that's why I'm asking. If there are expensive joins or something, definitely it will increase the compute and then hence the cost. How we can like can we also discuss this topic later maybe? Not today,
yeah,
but maybe later. Optimization with respect
yeah,
to the
we'll look
billing.
around. So
Okay.
the storage billing model in Snowflake is
Yeah.
based on pay as you go also,
Mhm.
and
Yeah, it is as per
daily.
byte scanned actually, which I know, but I don't know means as per the storage actually.
What one?
It is like basically Snowflake calculates the bytes scanned, right? The scanned bytes basically I'm saying scanned bytes of data, and based on that it will do some calculations. But like how it exactly works, I am not aware actually about that. That's why.
Basically, it also depend upon the cloud provider you're using to select. Let's say if you're using AWS, Azure, or Google Cloud,
Mhm.
because these data getting stored in their premises, right? It's in S3 or any other. So pricing is based on your cloud provider and the reason also. So example, if you have 1 TB of data will vary the cost in AWS, Azure, and Google. So the typical rate is standard that I able to recall is somewhere I think 23 to $40 per terabyte per month. Yeah, that is all about this thing. Now, what all we can discuss on the theoretical concept here is, I was telling you this, the user interface, right? So this is the user interface where, you know, you can have your data here, you can add your data, you know, we have multiple other processing can be done, data products, you can go into sharing of your data, AML products are also there. Umo.ai, they have mentioned Genesis bot. So these are into multiple bots can be added here. And monitoring can be done here. Like you might have done anything, the query history, you can see here, everything here. So that is what, you know, let's say here you are loading the sample data with Python from S3 bucket. So this is one of the example. Can you see that?
Okay.
So like we have done into Databricks, the same thing, right? Import Snowflake, a Snowflake as Snowpark. From Snowflake.snowpark function import column. From Snowflake Snowpark type import structure page, structure type, integer type, string type, variant. Like in PySpark we had, right? These all the things. So then here I'm just importing a session Snowpark and started the session. Okay. And then we are creating or replace database sample data collect. SQL we are running here. Structure type is this. I'll quickly check. And if you have any question related to this, you can ask me. Yeah, so what all the things we're gonna discuss, let me just tell you. So we will be discussing these things. We'll be learning loading from AWS, table type, streams, architecture we discuss, load, will do the data, zero copy cloning, materialized view, data sharing, data masking, copy options, Snowpipe, data sampling, access management, unstructured data, time travel, scheduling tasks, partner connect, performance, fail safe, visualization, best practices. So this is the idea. So the hands-on part and all, I think I will be starting from tomorrow session. In the theoretical concept, whatever we have discussed, you know, you wanted to ask any architecture level understanding or any other stuff, you can ask me. We have discussed these things.